Hello and welcome. My name is Michael Clark. I'm an IT operations and tech industry consultant with Renaissance Tech and Media, where we help companies and organizations struggling with cybersecurity challenges to operate more safely, securely, and efficiently in the world of hybrid multi-cloud computing. Today, I'm here with Brett Hamill, Senior Solutions Architect at Genians, a company that has helped over 1,600 customers around the world since 2005 to secure their network edge with next-gen network access control. Also joining us is David Zanoni, Technical Marketing Engineer at Infoblox. Infoblox provides enterprise-grade DNS, DHCP, and IPAM solutions to 93 of the Fortune 100 and many other customers globally. Mitigating risk in today's cyber threat landscape has proven to be an extremely challenging task for security professionals. A recent IBM analysis found that enterprise security teams use over 80 different cybersecurity products from 40 different vendors on average in their customers' environments. Conceptually, we all know that an integrated approach is the best for detecting and mitigating cybersecurity threats. But how can we actually orchestrate our cyber solutions most effectively? And how can we most efficiently maximize our cybersecurity resources without bringing on needless complexity? Of course, with network access control capable of locating and controlling any non-compliant or compromised devices at the network edge, it serves as the key component necessary for establishing an effective cyber defense framework. It can also orchestrate an organization's security products by integrating them with a wide range of IT security solutions, from IPAM to next-gen firewall, to IDS, IPS, to CM, and so on, all to ensure unified policy enforcement. Today, we're going to discuss how Genians and Infoblox integration efforts enhance the ability of Infoblox DDI with zero-touch, vendor-agnostic, layer 2 ARP enforcement capabilities of cloud-managed Genian NAC. The result is the ability to isolate devices identified as a threat at layer 2, blocking both internet and local traffic, and displaying information to the end user via a captive web portal. This both secures the network at the point of connection in real time as new threats are detected, and educates end users regarding the security status of their devices. So with that, I'm going to turn things over to Brett Hamill to begin our presentation today.
Thank you, Michael, and thank you everyone for joining us today. For those of you returning, you may be familiar with this webinar series where we've been focusing on different capabilities of the Genian NAC product. And for those of you joining us for the first time, we hope you enjoy today's webinar. So let's talk about today's webinar topics. First, we'll be providing the Genians overview to give you a functional overview of the next-gen multi-layer network access control capabilities of that product. Then there will be an Infoblox DDI overview that will discuss integrated enterprise-grade DNS, DHCP, and IPAM capabilities of Infoblox DDI. We will talk about the integration itself and provide an integration overview to discuss how the integration provides network security automation. That will be followed by a live demo of the integration itself, and then of course Q&A at the end. What is Genian NAC? Before we get into the details of exactly what Genian NAC is and what it's capable of, it's important to talk about the 3 critical steps for cybersecurity so we understand how network access control in general fits into the cybersecurity picture. In past webinars, we've done very detailed deep dives on surveillance capabilities of Genian NAC, which obviously is the first thing you want to do when it comes to cybersecurity. Subsequent to that, we've had webinars on the control aspect. Once you've surveilled your network, how do you actually control devices connecting to your network, make sure they're compliant with policies, and then assign the appropriate privileges for those devices. Today's webinar will be focused on the automation aspect of network access control and how that fits into cybersecurity. And this is a key objective so you don't have a situation where your cybersecurity plan requires too much manual intervention, which is not time sensitive enough to address real-time threats and just does not scale. What we see here is the common requirements for regulatory compliances going across various industries. So we have 6 of the CIS basic controls listed here and how they apply to these various regulations. According to the Center for Internet Security, just by implementing these 6 basic controls, you can likely defeat over 85% of all common attacks. Why is that? It's because the groups that are out there looking to exploit your vulnerabilities and entry points and look for attack vectors in your network, they always look for the low-hanging fruit. So by having these basic controls implemented, that's why you can avoid so many of those attacks, because you remove that low-hanging fruit from your network, and therefore you can defeat so many of those common attacks. If you think about those core requirements and those basic controls, what we're illustrating here is how network access control actually can address each one of these. So if you're talking about actually inventorying your hardware assets and controlling your assets on your network access control can detect all IP-enabled devices on the network and identify what type of device that is. So there's a direct correlation for that specific requirement to a feature that network access control can provide. When it comes to software, network access control, again, has a feature to address that. It can collect installed software on your devices so you can inventory and control your software. Continuous vulnerability management. This is key with part of what we're going to be discussing today to be able to leverage network security automation through integrations to manage devices that may be affected by vulnerabilities. Controlled use of administrative privileges. Those of you who have joined previous webinars, we talked about this extensively as well, how to control network access, and then based on various criteria, make sure that those have the appropriate privileges. Number 5, secure configuration of hardware and software on the devices themselves. So with NAC, you have the ability to inspect the configuration and security settings and maintain a security baseline. Most NAC agents provide some form of that capability. Last, with number 6, maintenance, monitoring, and analysis of audit logs. So it's key to actually provide real-time logging and reporting for all security-related events, to have that audit trail, and to be able to meet that requirement. And that's another feature that NAC can provide. So now that we know that network access control is key to any basic cybersecurity plan, and we've discussed how the specific network access control features map to those core cybersecurity requirements, we'll talk a little bit more about how network access control functions. With Genians network access control, there are key pieces to the architecture that allow us to perform the steps that we previously looked at when we were talking about those cybersecurity requirements. So dynamic node grouping, this is important because you have to be able to classify your devices into particular groups. Once you have the visibility, if you don't group them properly, then you can assign the appropriate privileges and create the appropriate policies. So Genian comes with over 500 predefined conditions right out of the box to help users actually group these devices together, and therefore they can be rolled into enforcement policies. So your enforcement policy can be based on all sorts of different statuses of the endpoint itself, compliance or other criteria. So once you group your devices together, link it to an enforcement policy, then you can decide what to do next, which is either going to be to provide specific granular permissions, least privileged permissions to those devices, or to quarantine them from the network if they're not permitted. How you actually do that depends on what product you deploy. With Genians, there's a multi-layered security approach, meaning there are several different architectures that you can implement with Genians NAC to actually provide the security that gets enforced once your enforcement policies are enacted. Today, we'll be focusing on the layer 2 ARP enforcement with the Genians network sensor. We consider this our most popular implementation method and has many benefits over some of the other architectures available. Although we have all sorts of different options for you, this is the most popular, we believe the most effective, and we'll talk about why. In addition to that, you have a radius option with a built-in radius server, SNMP enforcement capability, mirror ports, inline option, and then of course, you have the option to control devices with an agent. Honing in deeper on the ARP enforcement implementation method we discussed a moment ago, this slide details the key components that are part of the architecture to allow that deployment to be implemented on your network. The key pieces here are the policy server itself. The policy server can be implemented in the cloud. Genians has an AWS cloud. You can actually deploy this in a region of your choice, and you can deploy that very quickly straight from our website in about 5 minutes. If you prefer, you could have a policy server on-prem as well, and that could be a physical appliance or it can be virtualized. The policy server communicates with network sensors. Network sensors are the devices that perform the ARP enforcement on the network. Network sensors can be deployed at various locations in the network, depending on your network topology. Simply connecting the network sensor to a trunk port and tagging the interesting VLANs is all that needs to be done. There is no network integration required aside from connecting the trunk port. The sensor can operate in a passive or active mode where it's monitoring or enforcing policies. This is a very unique implementation method that allows you visibility without having to any downtime or do any network integration and any network disruption. Some of the contrasts from some of the other implementation methods, there's no requirements for the network environment. Your network environment does not have to support radius, SNMP, port mirroring, or any other similar features. There's no edge switch controller or access point configuration required. High availability is not required because this enforcement mechanism fails open, not closed. The only thing more important than network security is network availability. Because ARP is not tied to any particular vendor, this is the only method that is truly vendor agnostic. All other enforcement mechanisms are tied to vendor or some configuration unique to a vendor in one way, shape, or form or another. Also, rapid deployment is the key here. It's only 10 minutes per policy server or sensor. Those can be physical or virtual, provided via an ISO image and installed very rapidly, which is a key to success when it comes to deploying network access control.
Okay, thanks, Brett. We're now going to turn things over to David to provide a brief product overview of Infoblox DDI before we then move on to the following section, which covers the integration specifically. David?
Thank you, Michael. As mentioned, I am David Zanone, technical marketing engineer for Infoblox. If you're unfamiliar with Infoblox, we offer a wide variety of both on-prem and cloud-native network services such as DDI, DNS level security, threat intelligence, and much more. In this webinar, our focus is DDI and how Infoblox with Genians improves your security posture, ability to automate time-sensitive tasks, and improve the general ROI of both products. Let's delve a little deeper into Infoblox DDI. What is DDI, and why is Infoblox a great choice for this service? DDI stands for DHCP, DNS, and IPAM. Infoblox's DDI features a purpose-built security-hardened appliance that can be physical or virtualized. Infoblox's DDI also features a secure integrated database storing all of your network's data in a resilient fashion. This is possible using Infoblox's grid architecture that features a modular design and features effective redundancy. Finally, Infoblox's DDI offers powerful automation for time-sensitive tasks using various tools such as templates, wizards, APIs, and attribute inheritance. This automation empowers administrators with efficiency and accuracy and allows for certain tasks to be completed without direct intervention. Next slide, please. One of the biggest challenges of today's network infrastructure is security. As with everything, a good foundation is paramount. By understanding what the lowest common denominator is in networking, we can improve network security and also maximize the ROI of a network. This is where Infoblox's DDI comes in. Let's take a look at DDI as sort of a cornerstone of the networking foundation. First, DNS. That's the foundation of every network conversation. Without it, the internet is just a messy conglomeration of IPs. Furthermore, DNS without the correct protection becomes an easy attack vector for cybersecurity threats. Next, DHCP. That's the foundation of network access. With BYOD and IoT becoming more and more common, effective and secure DHCP is increasingly important. Finally, IPAM. An IPAM database must be the authoritative source of data regarding all network connected assets. At Infoblox, we think the solution to a more adaptive security architecture is to secure from the foundation up. How do you secure your network from the foundation? You look for the lowest common denominator and start there. When you start at this level, you have the best opportunity to improve your ROI. Next slide, please. Infoblox's ecosystem integration powers the Infoblox product with a large catalog of various products, some of which you may already be using. Here we can see a sample topology that showcases an Infoblox grid with many modular services. Our focus is the Infoblox grid, the external threat feeds, and the integration with the Genians NAC. By itself, the Infoblox grid empowers physical, virtual, or cloud-based DDI appliances with automated, distributed, high availability, and easy to manage core network services by a single pane of glass. With the current integration with the Genians NAC, we effectively quarantine malicious activity that may be occurring within your network. Malicious activity is determined by external or custom threat feeds, notifying the grid that intervention is required. With that, I'll pass it back to Michael.
Thanks very much, David, for that overview. Brett's now going to discuss further how the two systems integrate before we jump into our live integration demo. Brett?
Thank you, Michael. Thank you, David. So let's take a look at how the integration between Infoblox DDI and Genian NAC functions. The key here is to have actionable intelligence. What we mean by that is just not data that is in a vacuum and sitting in one system without any context. With the Genian NAC overview, we discussed how there's network surveillance and visibility with all the devices connecting on the network. There's context, who, what, when, where regarding all the devices. And because of that, we're tracking that information. Genian NAC has the ability to use its vendor agnostic enforcement capability to control access when it's deemed that there's a requirement to do so. Infoblox, on the other hand, excuse me, is monitoring all response policy zone security event tracking. So it has a running tracking event log of any type of event inside of a response policy zone in Infoblox DDI that may require some kind of attention. It's monitoring anomalous behavior of all the hosts that it's responsible for and generates the appropriate alerts when something is deemed a threat. If you look at the integration highlights between the two systems, what we're really doing here is we're extending the Infoblox RPZ capability. RPZ threats are forwarded to Genian NAC, and we leverage the zero-touch vendor-agnostic Layer 2 quarantine capability in Genian NAC to isolate the threat. The result is both external and internal traffic is blocked in real time. When we compare this to some legacy threat detection and quarantine methods, the distinction is clear. If you have a system, such as a SIM, IDS, IPS on your network that is monitoring events from various sources, there are only so many ways that you can output this data and leverage it. If you output alerts only and someone has to actually review those, you're talking about manual remediation. This is very resource intensive, it's not real time, and it simply does not scale. Another common option is to output your events to a next-gen firewall. What you find here is it's going to be platform dependent, so the integrations may vary in their capability. It only blocks internet traffic, so that leaves your network vulnerable, and all east-west traffic is exposed. You could potentially output these alerts to a radius-based NAC solution. Ultimately, what you have there is complex integrations. They're highly vendor dependent. They typically introduce a single point of failure, which means high availability has to be introduced. All of this adds up to a lengthy deployment, which means your network will be vulnerable longer because it'll take you longer to implement that solution. If you send your alerts to a layer 3 NAC system, using port mirroring, spanning, or some other similar solution, you could potentially have load or capacity concerns for large enterprise networks. Typically, a TCP reset enforcement method is used, and that may leave UDP or ARP traffic unchallenged, again, leaving your network vulnerable. Using an endpoint NAC enforcement, typically with that type of solution, you have to have an agent or a plugin that's required. That means it's not BYOD and IoT friendly because you're going to have different kinds of devices, mobile devices, privately owned devices, or IoT devices that may not support an agent. In that situation, you're going to leave your network vulnerable and you're not going to be able to cover as much of your network as you would like to because of those dependencies. Finally, Active Directory NAC enforcement is another option. Again, this typically requires an agent or a connector. It's not BYOD or IoT friendly because BYOD and IoT devices typically are not part of Active Directory and not on the domain. That's also platform dependent and leaves your network vulnerable. So here are some of the problems with the legacy threat detection and quarantine methods. So how do we address that? With the Genians and Infoblox DDI security automation integration, we address all the shortcomings of some of the various options. First and foremost, of course, we know Infoblox DDI is part of the network infrastructure and is monitoring all the hosts it's responsible for anomalous behavior. Once it identifies those threats, it forwards that to the Genian NAC. Genian NAC will match that on a quarantine policy and perform real-time layer 2 quarantine. That means that all traffic, not just north-south, but east-west, same segment traffic is isolated. This is not a complex integration, and it can be set up in just a few minutes. There are no agents, plugins, connectors, or other add-ons required. So with that, we're going to jump in and take a look at a live demo of this integration. First, we'll cover some of the components that are in our demo environment. First, we have a Genian NAC virtual instance deployed. We'll log into that and we'll look at the data in the dashboard before we begin our demo. So here you have the main dashboard view of Genian NAC. We're going to drill down to what is going to be specific for this demo. There's several nodes that are on this network. This node right here, 172.0.0.20, is what we're going to be using for this demo. So this is our Windows test machine that we will be isolating when it actually violates a security policy. The policy that this is going to match on is called Infoblox Quarantine. What we're doing with this enforcement policy is we're dynamically assigning a tag anytime we get a threat from Infoblox via a syslog alert. So no complex API integrations required there. We're going to assign specific permissions when you have this tag assigned. Here we only allow a few permissions. Intentionally, we allow DNS, so captive portals will load. We're allowing traffic to the Genians policy server, and then our management machine we're using for the demo. Also, we've configured an optional captive portal page where you can customize whatever messaging you want. This allows your end users to be educated, know what's happening, know why they're quarantined. If you just black hole someone, they don't know what to do, and they'll just call the help desk saying they have no network access. So here you can include things like auto remediation or other information to convey to the end user that there's a threat or an issue with their device, and you can even provide some kind of action here. Next, we have the Infoblox Grid Manager. Inside of here, you have a configuration that we're going to review later that will actually send syslog events to the Genian NAC anytime there is an issue or an event or a threat that it deems necessary to export to the Genian NAC system. Finally, we have our test machine. So this was the node we looked at earlier. This test machine has internet access presently. We have connectivity going to two different destinations. We're going outside the network, north-south traffic to the internet, and we're actually on same segment pings going as well to other nodes, another node on the exact same network segment. So that is the demo environment itself. What we're going to do here is we're going to actually simulate malware traffic. So we have pre-configured a test site that we're going to use as a malware site. What you'll notice here is that this did not resolve, so this page did not load. Also, you noticed almost real time, maybe 1 or 2 seconds, both east-west and north-south traffic has been blocked. In addition to that, you can see by doing an NS lookup, you're getting non-existent domain. That is Infoblox DDI. The Infoblox DDI is saying this domain does not exist. That's what it typically does when it has a blacklisted or a suspected malware site NS lookup. It actually provides that back to the device that's doing the query, and then it won't be able to resolve that name. However, that device still would have network access had it not been for the Genian's layer 2 quarantine methods that we talked about earlier. Now let's take a look at the device inside of Genians. If we go back now and we look at the enforcement policy, we now see we have one node matching on this policy. If we click on that node, we'll see that is the node in question. It now has the Infoblox quarantine policy instead of the default policy. So the permissions that we discussed previously have now been added to that device, and that is why the device has been blocked. If we look at the logging, we have a log filter for detection threat from Infoblox, and here we see the non-existent domain RPZ threat message that came from Infoblox to Genians, and this is what facilitated the real-time layer 2 quarantine of that device. So what we're going to do now is we're going to take any questions about the presentation itself or of the live demo.
Right. Let's thanks, Brett. That's great. Let's look at the questions that have come in since the webinar began. First up, what other actions can Genians take if a device on the network is identified as a threat?
Okay, let's take a look and see what options we have here. So we previously looked at the enforcement policy. Anytime we get a threat from Infoblox, we're going to take some kind of an action. So we know what we did was we used our ARP enforcement and we assigned these permissions with the layer 2 vendor agnostic ARP enforcement. We also enabled an optional captive portal. Above and beyond that, if you had the desire to do something else, there's additional capability. For example, you could use an SNMP switch port disabling, so you can enable that. In addition to that, you can actually use radius as well. So you could actually say, send back a radius attribute, such as a VLAN, quarantine VLAN ID, or a downloadable ACL, some other kind of attribute specific to your radius environment that would be sent back to a wireless controller access point or a switch. So you do have other actions and methods you could take. And at least, last but not least, you can also do an agent action if your devices on the network have agents installed. So lots of different options of how to enforce once you actually fail this policy.
Right. looks like the second one now is for David. How does Infoblox DDI determine which sites exactly are blacklisted?
Hey, thank you for your question. This is done via response policy zones. At its core, response policy zones control what your users can and cannot recursively look up via DNS. This can be seen as a sort of advanced or smart blacklist. These response policy zones are configured one of two ways. You have the option of manually configuring what you want to blacklist, kind of the archaic way, or you can enrich your feeds or acquire feeds from Infoblox that are enriched with threat intelligence and event metadata. RPZs really address DNS security in an agile way, in a way a lot of similar products don't. As you can see on the screen here, this is the local RPZ that was configured manually for the demo environment, showing that you're going to get blocked if you try to access docs.genians.com.
Okay. So back to Brett. How difficult is it to configure Genians to process alerts from Infoblox? Can you recap once again the steps required to do that?
Certainly. So as we discussed a little bit earlier, the more difficult an integration is to set up, the less likely it is to be successful or to ever be implemented at all. So having something very simple, quick, and easy that you don't have to have a low-level knowledge of security or networking to enable is key to being successful. So on the Genian side, we looked at most of the configuration. The key piece here that is actually triggering the policy enforcement is actually underneath the logging. So if we go to the detected threat from Infoblox log filter, we're matching on this information, RPZ QName NX domain that's coming from Infoblox. What we do with that log filter is simply assign a security tag. So you just add a tag, and here we're adding the Infoblox malware tag. As soon as that tag is dynamically assigned, which happens in real time, you saw how quick that node was quarantined, then that particular device matches on the policy, and we do whatever enforcement methods you have configured. So very easy to set up. On the Infoblox side, the simplicity is also very evident here. So under your grid configuration and your settings for Infoblox, under monitoring, you simply actually create a syslog server and point that to the Genians IP of your policy server, which is right here. Leave your default information, and then select what you're going to send. In this case, we're sending DNS, RPZ, and responses over to Genians, and that is actually what triggers the log filter on the other side and facilitates the policy enforcement.